Hey all, so we're going to talk about 1110, number 17, which was the problem that got nominated from this assignment. So if you're stuck on any of the other ones, please, of course, let me know either in the comments, set up a Zoom, or you can just fill in the form and I'll look at it again on Friday. So number 17 says, write the Taylor polynomial for the function, in this case 1 over root x, where a equals 9. So we're looking for the series from n equals 0 to infinity of the nth derivative, in this case at 9, over n factorial times x minus 9 to the n. Sorry, running out of space a little bit. So the main part here is the nth derivative at 9. Everything else, it just sort of stays like that. So what I'm going to do in this case, I'm going to give myself a little space here, is just like in the notes video, going to make a little table here where we're talking about our derivatives of x, and then at 9, because this is what we're actually going to plug in, and we're just looking for the pattern here. So 0, I'm going to write this as x to the negative 1/2, because then we can just use the, as we keep taking the derivative, it's easy to just use the power rule. So for 1, that's a negative 1/2 x to the 3/2. 2, that would be positive 3 over 4 x to the negative 5/2. And so hopefully we're ending up with 1 times 3 times then 5 over 2 times 2 times 2, x to the negative, in this case, 7/2. So I'm seeing an odd factorial in the numerator, and then an even powers in the denominator, like that, right? And when I plug in 9, then I'm going to end up with powers of 3. So when I plug in 9, right, this is 3 to the negative 1, 3 to the negative 3. What would that be? 3 to the negative 5, and then times those coefficients here, because the over 2 is the root. So I'm taking the root of 9, and then like so. So this is the pattern that I'm starting to see here. I'm also going to end up with an alternating portion. So negative, positive, negative, powers of 3, powers of 2. In this case, it's going to be 3. This one, it would be 2 squared, 1 over 2. And then we've got a factorial with odd numbers in the numerator. So we've got these 3 components to the nth root. Sorry, the nth derivative. So I'm going to have the alternating part first. That one's pretty easy to write. So it starts out positive, so negative 1 to the n, and then times 1 times 3 times 5 times ... all the way out to 2n minus 1, because you could write odd numbers like this. There's also a shorthand for odd numbered factorial, which you don't see very often. If you want, is n double factorial, so it's like 2 exclamation points, but then that gets confusing because you want to like cancel it out. So you can just leave it like that, as the odd expanded term like that. And then we have, these are negative powers of 3. So I'm just going to put that in the denominator here. They're always odd as well. So 2n starts at 1 at 0. So this would be plus 1. And then powers of 2 in the denominator, which is exactly matching up with those. Okay. So this is our nth derivative of 9. So then I'm going to go fill it into my series problem, n equals 0 to infinity, negative 1 to the n times 1 times 3 times 5 times 2n minus 1 over 2 to the n times 3 to the 2n plus 1, and then n factorial, that's just from the formula. So that's the whole coefficient, just checking my work really quick there. And then times x plus 9 to the n. So this is a whole big thing. It's not super pretty. When we do, they want to find the radius of convergence. So since I see a bunch of factorials here, I would use the ratio test here. I'm not going to put all of the algebra out here, but ratio test to here, you should end up with a bunch of stuff canceling out. So you should end up with, in the numerator, the -1, you'll have a -1 left, and then a times 2 to the n plus 1 from this next odd number after that, and then an x plus 9 over a 2 in the denominator, let's see, a 3, because there'd be 2, this would be 2 to the n plus 1, and then 2 to the n, so just 2 to the n minus 1, so that's a difference of 2, and then in the denominator here, n plus 1. If you want to expand everything out, I strongly encourage that. And then we set that less than 1. As n approaches infinity, what you'll end up dropping is, you can drop the plus 1, which is you can simplify that, which means you can simplify that. The -1, it's an absolute value, so you get the absolute value of x plus 9 over 3 squared, which is 9, has to be less than 1. Multiply the 9 over, and you end up with the radius of 9, which goes between x equals 0 and x equals 18. Let's see. -18. There we go. All right, so I know I skipped some steps with the algebra in this one, but please let me know if you have any other questions.